So what happens to the situation where the median does fall within the boxes? Okay, so if we take this median for A, we can see it falls in the box. So we can no longer say that A, half of A, is bigger than 3/4 B because it's too close. Okay, it's got into the box, so we cannot be sure about that because we don't know how many things are sitting in there. So no, we can't make that call. So no, we can't make the call there. So you need to look at the other median. So the median for B falls outside of this box. It doesn't fall inside the box. So therefore, we can still make the call. You only need to have one median outside of the box to be able to make the call. Okay, so in this case here, we can say that 3/4 of A is bigger than half of B, and that is enough evidence to say that we think in the populations A will tend to be bigger than B. Okay, so you only need one median outside the box. This one doesn't work for us. What happens if both of the box medians are inside the other one's box? Now, in this case here, the median for A is within the box for B, and the median for B is within the box for A. And in this case, it is too close to call. So if you can imagine that these are samples from a population, and this is the jitter there, and that's the jitter there, then you would say that they're actually pretty much in the same place. And so therefore, it would probably be, it is too close to call to say that A tends to be bigger than B. Don't say that they tend to be the same. You are trying to refute the question. The question says, does A tend to be bigger than B back in the populations? The answer is no, I can't be sure that A tends to be bigger. What happens if you get that? Well, the same thing goes, okay? Then they tend to be very similar populations. So you say that, no, I can't make the call that A tends to be bigger than B back in the populations. And in this case here, they look exactly the same, and you would be right to say that A and B look very much the same, and therefore A does not tend to be bigger than B back in the populations. And that's the call that you make. You can't make the call that they are different. Let's go to the controversial one. What happens if you get the median that actually is exactly the same as the lower quartile or the upper quartile? See here, the A median is within that other box, so you can't regard that one. Looking at the B, the median is actually right on the lower quartile. So in this case, it is actually too close to call. Okay, it's the same. It's too close to call. It's not possible to make the call, so A does not tend to be bigger than B back in the populations. Why is that? Well, if you took a little bit of a jitter there and you took a little bit of a jitter there, well, it could go either way. Okay, so therefore you always take the conservative call and say it is not possible to make the call in this case based on these samples. Okay, if you're looking for A to be bigger than B, and this is where a lot of people get confused, we're looking for A to be further up the scale. Well, the problem in this case here is that A tends to be down the other way. Now, what do you do in this case? What you need to do, because you're answering external questions, you need to actually answer the question first. Does A tend to be bigger back in the populations? There is no evidence here to say that A tends to be bigger. In fact, it looks like A would tend to be smaller. And then you go through, can I make a call? Okay, in this case here, the medians are within the other one's box. So no, you can't make a call that A tends to be smaller than B, or B tends to be bigger than A, but you certainly cannot you have to refute that claim first. And the same thing goes like that. Does A tend to be bigger? Oh, obviously A tends to be smaller, but you need to say first, A does not tend to be bigger back in the population. A looks like it's probably going to be smaller. Okay? And do the same thing.